This video is on solving compound inequalities. Compound inequalities are two inequalities that are joined by the word and or by the word or. An and inequality means that both of the inequalities must be true. So for example, x is greater than 2 and x is less than 5. The only values of x that will work are those that are both greater than 2 and less than 5. Numbers such as 3 or 4 or 2.5 or any number of the infinite number of numbers between 2 and 5. Here's what a graph of that looks like on the number line. So if I were to put 2 here, 3, 4, 5, I don't need to fill in all of these numbers, just do a couple. Okay, x is greater than 2 looks like this. X is less than 5 looks like this. Now I need all of the values that work in both of those. So that's going to be this region right in here where the inequalities overlap. So my inequality is going to look something like this. What is the overlap of those two graphs? It's where x is greater than 2 and x is less than 5. An and inequality can also be written without the word and. Since x is greater than 2 means the same as 2 is less than x, notice that my inequality symbol, the larger part, it's opening up to the x and pointing at the 2. Same thing over here. So x is greater than 2 means the same as 2 is less than x. So if I take 2 is less than x and put it right next to x is less than 5, I get this expression right here. 2 is less than x, which is less than 5. I really like writing the inequality that way because that looks a lot like what my graph looks like. If I were to graph that, I'm going to do that very simply over here with just a 2 and a 5. So x is less than 2 and x is greater than 5. That's what my inequality, the graph of it, looks like. And to me that looks a whole lot like this. X is any number that's between 2 and 5 on that graph. An or inequality means that either one of the inequalities can be true. So for example, x is less than 2 or x is greater than 5. The values of x that work in this compound inequality are all of those that are less than 2 or greater than 5, such as 1 or 6. Let's take a look at what that looks like on a number line. Oops, oh, sorry about that. This up a little bit. So I'm going to go ahead and do 0, 1, 2, 3. Okay, so x is less than 2 or x is greater than 5. So all of the values that are less than 2, so like 1 and 0 and all of the numbers, even like 1.999 would satisfy that, or anything that's greater than 5, like 6, 7, or 8, or even 5.00001 would work as well. An or inequality must be written with the word or. You can't put it together the way we did with an and inequality. If you were to put it together something like this, 2 is greater than x, which is greater than 5, just doesn't make sense because 2 is ultimately not greater than 5. So an or inequality needs to be written like this. X is less than 2 or x is greater than 5. You need to leave that word or in there. To solve a compound inequality, we're going to solve each inequality separately and then join them with the word and or the word or in your solution. So let's solve each of these compound inequalities, and then graph our solutions. So the first one is x plus 2 is less than or equal to negative 5 and x plus 6 is greater than or equal to negative 6. So I'm going to subtract 2 on each side, do each one separately. So x is less than or equal to negative 7, and let's subtract 6 on each side. X is greater than or equal to negative 12. Now I can put the two of these together if I would like. Negative 12 is smaller, so I'm actually going to put that over here. So negative 12, and my inequality needs to be pointing at the negative 12, and x is less than or equal to negative 7. Notice that if I took the x out, I would have negative 12 is less than negative 7, and that's true. That's the way it needs to, has to make sense that way. So I'll do negative 12 and negative 7, and solid dots, since both of these are or equal to's, and a solid line in between. So x is any number that's between and including negative 12 and negative 7. So here's my solution, and there's my graph. Number 2 says negative 2 is less than or equal to the quantity x minus 3, which is less than 4. So notice this is an and inequality written without the word and. It means x is less than or equal to x minus 3, and x minus 3 is less than 4. I can actually solve this written this way because remember, look at the way my answer is written here. I have just an x in the middle. So my goal is to get just an x in the middle here. To do that, I can add a 3, but if I add a 3 in the middle, I have to add a 3 on each side. So those will cancel out or give me a 0, leaving me with an x in the middle, which is going to be less than 7, and x is going to be greater than or equal to 1. So my answer is 1 is less than or equal to x, which is less than 7. Graphing that on a number line is going to look like this. I'll have a 1 and a 7, and a solid dot over the 1 because this is a or equal to, an open circle over the 7, and then they are connected by a line. So the solution for this is any number. It can be 1, it can be anything greater than 1, up to, but not including 7. And our last inequality is actually an or inequality, so I need to make sure that I have the word or in my answer. So solving each part separately, I'll subtract 14 on each side, and that's going to leave me with x is greater than 1, or adding 9 to both sides of this one, x is less than negative 1. So x is greater than 1, oops, it's not a very good greater than sign, x is greater than 1, or x is less than negative 1. And let's graph that. So I have negative 1, positive 1, x is greater than 1, so open circle because these are not or equal to's, and x is less than negative 1, open circle going that way. So in this video we took a look at how to solve a compound inequality. Remember that a compound inequality is two inequalities that are joined by the word and or. If it's an and, you're looking for the values of x that make both of those inequalities true. If it's an or inequality, you're looking for the values of x that make either one or the other of the inequalities true.